Okay, this is Engage New York Module 2, Lesson 28, Problem Set / Concept Development. Okay, so we are going to go ahead and just begin the problem set as our concept development. So, Ava is saving for a new computer that costs $1,218. She has already saved half of the money. Ava earns $14 per hour. How many hours must Ava work in order to save the rest of the money? So, number 1, step 1. We need to take half of the money to figure out. We know that she has half of the money, so we need to figure out how much money she needs to actually continue to save. That is correct. We are going to do the operation of division, and we're going to divide 1,218 by 2, and that's going to give us what amount of money she already has saved, or how much money she has, how much more she has to save. 2 goes into 12 6 times. Bring down the 1. Bring down the 1. 2 goes into 1, 0 times, and this is that step that people mess up right now, right? I see this problem. I see this happen. So 0 times 2 is 0. Subtract, bring down the 8. Now we're working with 18. 2 goes into 18 9 times. So Ava has $609 saved, and that means she needs to now still make $609. So what we do know is that she makes $14 an hour at her job. How many hours must Ava work in order to save the rest of the money? What should we do now? What's next? We're going to divide now $14 into $609. So now 14 goes into 60. Well, 60 and 14, if I round 14 to 20, I would go
5 times.
What? If I round 14 to 20 and I go 20 goes into 60, about how many times? 3 times. Let's try 3. 3 times 4 is 12. 3 times 1 is 3 plus 1 is 4. So let's see how we do and see if we need to go up. Oh, looks like we need to go up, right? Okay, so 3 didn't work. So now we're going to go to 4. 4 times 4 is 16. 4 times 1 is 4 plus 1 is 5. Now we're closer. 60 minus 56 is 4, right? Bring down the 9. How many times will 14 go into 49? So if we use our estimation skills and we go 20 and 50.
3 times.
You guys, okay, let's try 3 times. Oh, because we did multiply 3 last time, right? And we got 12, 3, 4, we got 42, correct?
Yeah.
All right, well, we still don't know. So we have to add a decimal, add a 0, bring down the 0. How many times will 14 go into 70? 14 into 70. Okay, let's try it. 5. 5 times 4 is 20. 5, 6, 7. Oh, look at that. That ended nicely. So 43.5 hours to make $609.
Wow, that's a lot of work now.
It depends on how much she works in a week, right?
Yeah.
So wait a minute. This is something that I see on your homework, and this is, okay, let me rephrase it. This is what I'm not seeing on your homework. answering the question. You don't just leave numbers because that tells me absolutely nothing. This is your answer. This is what I check for correctly completing. Got it? All right, now Michael has a collection of 1,402 sports cards. He hopes to sell the collection in packs of 36 cards. So wait a minute. He is going to take this 1404 and put them in packages of 36. And he wants to end up making $633.75 when all the packs are sold. If each pack is priced the same, this right here, if each pack is priced the same, screams division for me. How much should Michael charge per pack? Well, what number are we actually missing?
That's very CGI.
What are we missing? What part are we missing? We know the total. So if you looked at it this way in an array, we know the total, right, of 1404, right? And we know that he's going to sell it in packs of cards of 36. So that means this is how much is inside in a group, right? What part are we missing? If this part is how many in a group, what are we missing over here in our array? If this is how many are in that group, we know there's going to be 36 in each group. What number are we missing? Oliver.
How many packs? No, not packs. So you're 36 cards and you want so many packs. You just don't know how many packs you need.
Exactly. How many packs? We don't know that information, right? So we're given one of these and we're given a total. That screams division, right? Exactly. So step 1, 36 divided by 1,404. And that's going to give us how many packages. Okay? So hopefully you have this information down right here to remind yourself of what we're doing. This is important information. This is how you figure things out. This is how you strategize on solving. So 36 goes into 1, no. 36 goes into 14, no. 36 goes into 140. Well, what if I round 36 to about 140, 140, 40 going into 140? Do you guys? Okay, let's try 3. 3 times 6 is 18. 9, 10. Okay, let's subtract. 32. All right, now 36 into 324. So 30 into 300, 30, 40 into, like, what do you think? What do you think?
9.
Okay, let's try 9. I like it. 9 times 6 is 54. 9 times 3 is 27, 28, 29, 30, 31, 32. Oh, look at that. So 39 packages, and this is the right answer. This is not the right answer. That is not the right answer right there. Guess what's the right answer is? 39 packages with 36 cards in each pack is the right answer. Now, how much should Michael charge per pack? So if each pack is priced the same, how much should Michael charge per pack? Because we know he wants to go. Now, we have to take step 2 is 39 packs into $633.75. This answer right here becomes how much he should charge per pack. Yes, this is the second part to the question. And if you do not have these things written out, your problem is not correct. Throwing a bunch of numbers on a page and like hoping I can figure out what you're saying, no, doesn't work. Anyway. All right, now we have Jim Nastium is building a treehouse for his 2 daughters. He cuts 12 pieces of wood from a board that is 128 inches long. He cuts 5 pieces that measure 15.75 inches each and 7 pieces evenly cut from what is left. Jim calculates that due to the width of his cutting blade, he will lose a total of 2 inches of wood after making all the cuts. What is the length of each of the 7 pieces? All right, so we have 12 pieces. We have 128 inches long. We have 5 at 15.75 inches and 7 pieces evenly cut. Sounds like division right there. From what is left. Calculate, he will lose 2 inches of wood after making all of the cuts. What is the length of each of the 7 pieces? So I'm trying to find the 7 pieces. Well, first, let's draw this out. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 pieces of wood from a board that is 128 inches long. So this whole thing, to here, is 128 inches long. Now we're going to take something that measures 128 inches long and we're going to cut it into 12 pieces. What we know is he cuts 5 pieces that measures 15.75. So we know that these 5, he cuts 5 pieces that measures, now this is 15.75 inches here. So what is the rest, right? So now what do we need to do first? So what do you think our step 1 should be? Step 1 is going to be to take 15.75 and multiply it by 5. And that's going to give us I have to put that back in. So 78.75. So this measures 78.75. So each one of those must measure 15.75 inches each. So 15.75 inches each times 5 gives us a total of 78.75 of this area right here. So what we need to do is step 2. We're going to go 128 and we're going to subtract 78.75 to figure out what we have left. And we end up with 17.9 and 11.5 is 4. So 49.25 inches left over. So this right here measures 49.25 inches are left over. So what are we going to do? We are going to take our, we're going to take, so what we know so far is that out of 128 inches of wood, 78.75 inches were cut off, right? Then we took the total and subtracted that 78 inches, and we got 49.25 inches left over. So now we're going to take that and see what the length of each of these 7 pieces that are left over, 1, 2, 3, 4, 5, 6, 7 are left over. So now we're going to divide it into 7 equal pieces. We're going to take 49.25. 7 is 49. Bring down the 2. That's 0, right? Now we're going to bring down the 5. How many times will that go in? 7 times 5 is 35. Oh, did I write down a number wrong? 9, 10, 11. Let's see. 35. 49.30. Oh, this did not need to be changed. Well, no, it had to be changed. So 7 goes into 25. 7 goes into 25. It can't go 4. It has to go 3, right? There's still 4 left over. I don't know if this is going to zero out. So 0, how many times will 7 go into 40? 0 is here. 7 times 6 is 42, so it has to go 5, right? So 5 is 35 with 5 left over. So we're just estimating now. So I'm going to round. We have to round. We're going to have to, on our last step, we're going to have to round this amount up. And because 5 rounds to 4, so let's go 7.04 inches is the length of each piece. Now, if I come over here, 7, 9. For some reason on the key, it has this being 35. But doing the math, if I go through and I can't take 0, I can't take something away from 0, so it has to borrow from 7. 7 comes over here. I add 1, but I can't. I have to take that away. I think they just made a mistake. So I think we are correct here. All right. A load of bricks is twice as heavy as a load of sticks. The total weight of 4 loads of bricks and 4 loads of sticks is 771 kilograms. What is the total weight of 1 load of bricks and 3 loads of sticks? So 1 load of bricks, 1 load of sticks. Okay, so at first, whenever we're reading a word problem, I always like to try to isolate my numbers. So and then write down what I know. And what I know is that bricks, 1 load of bricks is equal to 2 times 1 load of bricks is equal to twice as heavy as 1 load of sticks. So 2 times the sticks. That's what we know. Now, the total weight of 4 loads of bricks, so 4 loads of bricks and 4 loads of sticks equals 771 kilograms. What is the total weight of 1 load of bricks and 3 loads of sticks then? All right, so let's draw this out. 1, 2, 3, 4, 5, 6, 7, 8. Don't need this. Okay, so 4 loads of bricks. So here, 4 loads of bricks, 4 loads of sticks. So we have this plus this, right? So bricks, this equals the bricks because it's 2 times the sticks, right? So the sticks would be 9, 10, 11, 12, if you will. Now, if you add up the bricks and the sticks, that's going to equal 12 units. And 12 units is equal to 771 kilograms. So if we divide each by 12, we end up with 1 unit is equal to, and we're going to take this idea and we're going to go 12 divided by 771, and we're going to get 6 is 60, right? 6 times 12, is 72. It's 5 is 60. All right. 5, bring down the 1. This will go 4 times because it's 48. 3. Now we're going to add that decimal, bring down the 0. 12 goes into 30 2 times, and it's 24. You subtract, you get 6. Add another 0. Oh, there we go. We get our 60, and it zeroes out. Okay. Now now we divided this into this, and we end up with 64.25. Now, 1 load of bricks. A load of bricks is twice as heavy as a load of sticks. The total weight of 4 loads of bricks and 4 loads of sticks is 771 kilograms. What is the total weight of 1 load of bricks and 3 loads of sticks? So now we need to go back in and figure out 1 load of bricks and 3 loads of sticks. So where do we go from here? So now we need to calculate 1 load of bricks and 3 loads of sticks, which is 4. So now we need to take 64.25 and multiply it by 4. And we're going to get 20, 8, 9, 10, 16, 17, 24, 25, and add 2 zeros. We are going to get 257 kilograms. So 1 load of bricks and 3 loads of sticks is equal to 257 kilograms. Wait a minute. If bricks, what is the total weight? But one load of bricks is 2 times the load of bricks. So wait a minute. Instead of multiplying by 4, I should have multiplied by 5 because this is 2 times. So that means it's 64.25 twice plus these. So it should have been 64. See, going back and checking, what am I solving for? What do I know? 64.25 times 5 gives us 321.25 kilograms. That is your answer. So it is 321.25 kilograms. All right, good thing I caught that. All right, that will do it for this section of problem set. Now, let's go through just the homework and let's take a look at some of the problems on the homework. Now, so Mr. Wright needs to replace some edging on a flower box. Here, I started writing it out and realized, what are we really solving for? How many ounces of nuts are in each granola bar? We have 25 granola bars. Then we have some flour, and then we subtract some buns, and the remaining is divided equally between 15 batches. Then there are 90 fifth grade students. We have admission is equal. When you pay for that $9.25, you get both the theater and the lunch. And admission for all the students will cost $315. And if each student will get an equal amount to spend, and remember, there are 90 fifth graders. So think of that array. That's what I've done here. What part is missing? What part do you know? And what part do you need to solve for? So we know that each student gives the teacher $9.25 to cover 2 things. What we're looking for is how much does lunch actually cost? So you're given a lot of information, but this is what you're actually solving for. How much money does it cost for lunch? All right. And lastly, Ben is making math manipulatives to sell. He wants to make at least $450. Each manipulative costs $18 to make, but he's selling them for $30. So how much money does he expect to make on each one? And what is the minimum number he can sell to reach his goal? So this is his goal, right? So it looks like this might be a 3-step problem. You might have to do some subtraction and some multiplication and some division. So remember, what are you solving for? We know it costs him only $18 to make something, but he's going to sell it for $30. He wants to make this amount. So what is the minimum he can charge in order to actually reach his goal? So instead of putting Ben in the problem, put yourself in the problem. Pretend that you're actually trying to solve this problem and you're trying to make money. How would you go about making this money is the best way to try to solve this. All right. Remember, there's Eureka Math, 5th Engage New York, Module 2, Lesson 28, Eureka Math. And he does go through the homework problems if you need a little more help.